Next example. Let's try to do this without using our U's and V's because we should be able to do that to speed things up. So let's straight away, dy dx is equal to our first function, x to the power of -3 times the derivative of the second function. So this is equivalent to x cubed minus x, all raised to the power of 1/5, right? So applying the power rule combined with the chain rule, we get 1/5 times x cubed minus 3. And then 1/5 minus 1 is -4/5. And then by chain rule, the derivative of the inside, 3x squared minus 1. I'll just quickly erase this. Okay, so that's our first part, and then plus the second function. Let's just leave it as it is. X cubed minus x power of a fifth. And then derivative of the first function. So power rule, -3 times x to the power of -4. All right, once again, we have to simplify quite a bit. Now let's start putting all of this into fraction form, which can make it a little bit clearer to read. So remembering that negative indices become positive indices if we put them in the denominator. We have 3x squared minus 1 is our numerator over, so we have a 5, an x cubed, and then x cubed minus x all to the power of positive 4/5. Okay, and then on the right hand side here we have -3 times x cubed minus x. Oops. Power of a fifth over x to the power of 4. So let's get this term on the right hand side under a common denominator so we can simplify. So we need a 5. Okay, so multiply the top and the bottom by 5. And then we need this x cubed minus x all raised to the power of 4/5. We multiply something on the bottom, we have to multiply the top by that same factor. And we need to add a single x to the numerator and denominator of the left-hand side. So we have x to the 4 as our denominator on in both fractions. Okay, let's simplify now. So expanding the brackets on the numerators, we get 3x cubed minus x. And then here, 5 times 3 is 15. So we have -15. So because these brackets on the very right have the same expression inside, we can just add the indices. So 5th plus 4/5 is just 1. So 15 multiplied by x cubed minus x raised to the power of 1. And all of this gets divided by 5x to the power of 4 times x cubed minus x to the power of 4/5. We can combine like terms again, giving us, so 3x cubed minus 15x cubed, that should be -12x cubed. Okay, and then we have minus x, and once we expand the bracket on the brackets on the right, plus 15x. So that gives us plus 14x all over 5x to the power of 4 times x cubed minus x all to the power of 4/5. And we notice that we have x as a common factor in the numerator and in the denominator. So let's cancel that. Leaving us with our final expression, negative 12x squared plus 14 over 5x cubed times x cubed minus x raised to the power of 4/5. That's it. Moving on. Now we have e to the power of negative 4x as our first function, and our second function is square root of x plus 1. Therefore, using the product rule, f prime of x is equal to, so the first function, e to the negative 4x times the derivative of the second function, so a half x plus 1 to the power of negative a half, plus the second function, square root of x squared plus 1 times the derivative of the first function, which is e to the negative 4x multiplied by negative 4, right, by the chain rule. Therefore, so we notice that e to the negative 4x appears as a common factor, which we can put in the front here. And let's rewrite this as 1 over 2 root x plus 1 minus 4 root x plus 1. Or let's quickly put both terms under a common denominator. And I forgot a 2 as well, so 2 times 2 and this gives us e to the power of negative 4x times 1 over 2 square root x squared plus 1. And we have 1 minus, so 4 times 2 is 8. And then square root of x squared plus 1 squared is just x plus 1. So simplifying, we get, and let's put our e in the denominator as well. Right, so it becomes a positive index here, e to the positive 4x, square root of x plus 1. So in the numerator, 1 minus 8 times 1 is 1 minus 8, which is negative 7, and then minus 8x. Done. Next example. Okay, we have a natural log this time. F prime of x is equal to, let's just keep our constant in the front because it is not affected by differentiation. All right, so x squared times the derivative of the natural log of x, which is just 1 over x, plus natural log of x times the derivative of x squared, which is 2x. So 2 times, oops. And then cleaning this up a little, 3 times x plus 2x log base e of x. And if you wanted to, you could also pull an x out of both terms. Okay,